Hello, I'm Anthony Reason from the NIACC Innovation Workspace, and this is our first video showcase of a project created here. It's a bit of an experiment, so we hope you like it. We were asked by the Diesel Technology program here on campus to add a black vinyl sticker to the raised portion of a panel from a Caterpillar. The students are doing some work on this machine, and the panel was rather scuffed up. By adding this vinyl, we will be able to increase the contrast and really make the logo pop. Originally, our plan was to find a copy of the logo online, create a vector path from the image, and use our vinyl cutter to create the design. Unfortunately, the logo didn't quite fit the panel, and instead we decided to try a different, if slightly silly, approach. This is the NIACC Innovation Workspace's Creaform Handy Scan Silver portable 3D scanner. It projects a series of laser lines onto the surface of an object being scanned, and the two cameras detect the ways the light are bent due to the surface geometry and send the data back to the computer to be rendered into a 3D geometry in real time. While it sounds complicated, the scanner is actually incredibly easy to use. If you can use a can of spray paint, you can use this scanner. And while the scanner may be overkill for this kind of a project, it will let us pull the path directly off of the panel's geometry to use in our vinyl cutter. So, let's take a CAT scan. The process of taking a 3D scan involves a series of steps. First, we must prep the scanner by running it through its calibration and configuration routines. This allows us to ensure that the settings are optimal for the part that we are to scan. Next, we need to prepare the part itself for scanning. In this case, that is simply placing tracking targets on the surface of the object. After that, we are ready to scan, projecting the laser lines and recording the geometry. Since we are only scanning the logo on one side, the scan takes very little time. Once we have our scan collected, we shift to extracting the geometry we need from the scan data. We first create a plane using 3 points on the scanned surface and use that as the starting point to create a cross-section of the CAT logo. Then it is a simple matter to select the cross-section and export it as a drawing exchange format or DXF file. At this point, we switch gears from 3D to 2D. To prepare this file for cutting, we imported the path into Inkscape, a free vector graphic software. Inside Inkscape, we scale the design to the proper dimensions and then use the simplify path command to reduce the number of nodes and make the file much easier to work with. Finally, we save our modified design as a scalar vector graphic, or SVG, so it can be used in the vinyl cutter. The NIACC Innovation Workspace has a US Cutter's Titan 28-inch vinyl cutter. These machines are essentially computer-controlled razor blades, which allow us to cut through the top layer of vinyl while leaving the backing intact. We can create all sorts of customized stickers and decals to add to walls, shirts, computers, etc. But today, we are just going to be creating a simple black logo. With all that in mind, we can move across the hall and get the cutting started. The scalar vector graphic we created in Inkscape now serves as a path for the vinyl cutter to follow. And with a relatively small and simple design like this, it takes very little time to be cut. Once the design is made, it is a simple matter of removing the background vinyl, a process referred to as weeding, and applying the transfer tape. This tape allows us to move all of the pieces of vinyl from the backing onto the panel in one action, keeping everything together. Once in place, we apply a little pressure to ensure the decal sticks, and then we can peel back the transfer tape. And there we have it, a custom vinyl sticker designed from the geometry of the plate itself. The only thing left to do is to remove our tracking targets and get it installed on the machine. Thank you for coming along with us on this project. We hope you enjoyed it. If so, follow us on social media, info in the description, and give this video a like and a share so other people can learn about the interesting stuff we do here at NIACC. And if you like this kind of project, consider becoming a member of the NIACC Innovation Workspace to support us and gain access to these tools to create your own awesome projects. You can learn more at info.niacc.edu/innovate.